Assalamu alaikum, dear students. I'm your tutor, Dr. Rashid, in front of you, along with the class in NEET JEE Foundations. So yesterday class was about the previous questions that were asked in the AIMS exams, as well as NEET exams, as well as AI PMT prelims exams. So today we'll have another portion of questions that have been asked in the JEE advanced exams, right? These are not that difficult questions. They are also expected to be asked in the AIMS questions as well, right? तो पहला वाला क्वेश्चन लिखते हैं यहाँ पे, ठीक है बेटा। पहला वाला क्वेश्चन है, सो तो देख लो बेटा, दिस क्वेश्चन हैज बीन आस्क्ड इन IIT 2001. क्वेश्चन क्या है कि यूनिफॉर्म इलेक्ट्रिक फील्ड पॉइंटिंग इन ए पॉजिटिव एक्स डायरेक्शन एग्जिस्ट्स इन ए रीजन। एक इलेक्ट्रिक फील्ड है, देख लो बेटा, अगर मैं ये एक्स एक्सिस ले लेता हूं, ठीक है बेटा, ये एक्स एक्सिस है, यूनिफॉर्म इलेक्ट्रिक पॉइंटिंग इन ए पॉजिटिव एक्स डायरेक्शन, तो इसी डायरेक्शन में इलेक्ट्रिक फील्ड है, ठीक है बेटा, इन द पॉजिटिव एक्स डायरेक्शन, ठीक है बेटा, इन ए रीजन। लेट ए बी द ओरिजिन। चलो हम ये मानते हैं यहाँ पे, देख लो बेटा, यहाँ पे ए ओरिजिन है, लेट ए बी द ओरिजिन, बी बी द पॉइंट ऑन द एक्स एक्सिस, बी बी द पॉइंट, यहाँ पे ये बी पॉइंट हम ले लेंगे, ठीक है बेटा, बी बी द पॉइंट ऑन एक्स एट एक्स टू 1 सेंटीमीटर, दैट इज इट इज 1 सेंटीमीटर, ठीक है बेटा, इट इज 1 सेंटीमीटर, इट इज 1 सेंटीमीटर, हाँ, ये ओरिजिन है 1 सेंटीमीटर, एंड सी बी द पॉइंट ऑन वाई एक्सिस, और सी यहाँ पे पॉइंट है, ठीक है बेटा, सी यहाँ पे पॉइंट है एट 1 सेंटीमीटर, और ये भी वाई 1 सेंटीमीटर, ठीक है बेटा, ये इलेक्ट्रिक फील्ड है, ठीक है बेटा, ये इलेक्ट्रिक फील्ड है on y axis, then the potential at points A, B and C satisfy। तो इस डायग्राम को देखना है और देख के हमें ये बोलना है कि इनमें से कौन सा पोटेंशियल सेटिस्फाई कर रहा है इस डायग्राम को। देख लो बेटा, अगर आप लोगों को याद है जब मैंने आपको पढ़ाया था कि देयर इज अ रिलेशनशिप, मैथमेटिकल रिलेशनशिप बिटवीन द इलेक्ट्रिक पोटेंशियल एंड इलेक्ट्रिक फील्ड। ये क्यों हमने ड्राइव की थी कि जब मैंने आपको बताया था कि अगर इलेक्ट्रिक पोटेंशियल इनसाइड ए यूनिफॉर्म सर्कुलर शेल, यूनिफॉर्म स्फेरिकल शेल नॉन जीरो है, लेकिन इसी यूनिफॉर्म स्फेरिकल शेल के अंदर इलेक्ट्रिक फील्ड जीरो है, लेकिन इसी स्फेरिकल शेल के अंदर पोटेंशियल नॉन जीरो है, ठीक है बेटा। तो उस चक्कर में हमने एक रिलेशनशिप डिराइव की थी बिटवीन इलेक्ट्रिक फील्ड एंड द पोटेंशियल। वी डिराइव्ड ए रिलेशनशिप, दैट रिलेशनशिप वाज E is equal to minus dV by dx. Is it so? What does it mean? I'm trying to say that this is the electric field and this is the potential. So there is a relationship between electric field and the potential. Remember here, this electric field is a vector quantity, but this V is a potential quantity, right? This is a potential, right? So that means this V is a scalar quantity, is electric field, V is a vector quantity. So the point over here is this negative sign, right? So it means the direction of the electric field is in the decreasing direction of the potential. It means the direction of electric field is in the direction in which the potential decreases. So what I'm trying to say you that the direction in which the potential decreases, in the same direction electric field will be. That means the direction of electric field will be the decreasing direction of the potential. Got it? So here यहाँ पे देख लो, right? See now, electric field is along x-axis, as the question is itself mentioning the pointing in a positive x direction, that is electric field is pointing along the x direction, right? So it means, but the direction of electric field is in the decreasing direction of the potential. So it means if electric field is increasing if the direction of electric field is in this direction, that means in this direction potential will be decreasing according to this relationship, right? As I have already mentioned it, I have repeatedly told about it, that the direction of electric field is in the decreasing direction of the potential. It means, but according to the question, electric field is in the x direction, is along the x-axis. That means along this axis potential is decreasing. So it means potential, as we go away from the origin, potential will decrease gradually because from this relationship. So it means potential at B is less than potential at A. So it means potential at A will be greater than potential at B. Why? Because if electric field is along x-axis and the electric field has a direction in the decreasing direction of potential, so it means electric field has direction this. So as we go away from the origin, the potential will decrease. That means at point B potential will be less than the potential at A. So that means the potential at A will be greater than potential at B. So its option is B. I hope you understand. Okay beta, is it true? So it has Okay, beta. So V is greater than VB. Now coming to the another question. So beta, this is the another question that has been asked in IIT 1989. See, the question is speaking about the potential. The potential at any point x, y, z. What is x, y, z? X, y, z means these are three coordinates. As you know, in mathematics, in geometry, we have three dimensions. Got it? In higher physics, we have more than 4 dimensions space-time. Then we have in string theory, we have 11 dimensions. We should not go over there. So we have three coordinates, right? We have it's a one point having the coordinate x, y, z. It means the coordinate of a point in a three-dimensional plane x, y, z, right, is given by the potential at that point is given by 4x square. Got it? The electric field at the point 1 meter, 0 and 2 meter in volt per meter is given by. We have to calculate the electric field from this potential. See now, over here I have to use again the same relationship. See, again the same relationship. What is that? Again, that is E is equal to minus dV by dx. We know that the rate change of potential with respect to x is known as electric field, or the gradient of the potential gives the electric field. And one more important point to remember over here is the direction of electric field is always in the decreasing direction of the potential. That means the electric field aligns in the direction in which the potential decreases. Got it? So if this is the potential, right, got it? So E is equal to minus d by dx. Got it? Minus d by dx. What is potential? Potential is 4x square. Got it? 4x square. 4x square. So it's actually it's actually yes. So it means E vector is equal to minus times the different minus times 4 of d by dx of x square. Got it? So it means E is equal to, okay, it means E is equal to minus 4 times d by dx of x square. Differentiation of x square is 2x. Okay, got it? So it means minus 8 of x. But we have to find the question is asking what is the electric field at the point 1 meter, 0 and 2 meter, where x is 1 meter, 0, 2 meter. But as you know, the potential is only the function of x coordinate. So it means we don't have to use the y coordinate. We do use the z coordinate because the potential is only in the x coordinate. Okay, so it means we have to find electric field at x is equal to 1 meter. Okay, at x equal to 1 meter. So it implies that electric field is equal to minus 8 into x is equal to 1 meter. X equal to 1 meter, that is equal to minus 8 volt per meter. So it means the electric field from this potential is minus 8. So it means electric field is along negative x-axis. Why negative? Because negative sign is there. Got it? Why along x-axis? Because the potential is only the function of x. Got it? So it means the electric field is along negative x-axis. So it is 8 along negative x-axis. So this will be the option, correct option. So again I will explain this question. The question is asking, this question has been asked in 1989. The question is speaking about the potential V is equal to 4x square, which is given, and we have to calculate the electric field at the point 1 meter, 0 and 2 meter. So the question is itself asking that you have to calculate the electric field from this potential at the point 1 meter, 0 and 2 meter in volt per meter is. So I know that there is a relationship between the electric field and the potential which we have recently derived, that's minus dV by dx. So minus d by dx of what is potential? Potential is 4x square. So 4 goes out and the differentiation of x square is 2x. So it is minus 8x. So E is minus 8 volt per meter. So it means the electric field is minus 8. Minus means it's along negative. X-axis means because it is the potential. Potential is only a potential is a function of x. So it means electric field is on the x-axis but along negative side. So electric field is along negative x-axis. So this was the question which has been asked in IIT 1989. So let's come to the next question. So this is the question that has been asked in IIT 2002, right? The question is that three charges Q plus Q plus Q are placed at the vertices of a right angle triangle. So vertices of a right angle triangle. Okay, so this is the right angle triangle, isosceles, right? That means this and this side are equal, same, of a right angle triangle. Q plus Q and plus Q. Okay, that is Q plus Q and plus Q. Okay, plus Q and plus Q. The net electrostatic energy of the configuration is 0. The net electrostatic energy of electrostatic potential energy, it means electrostatic potential energy of three charges placed at the vertices of the isosceles triangle is zero. So if Q is equal to, now see here, okay. So solution here, we will write the solution here, okay, beta. Solution. I remember the class when there was a system of two charges or the system of three charges, for example, which were on the, it was Q1, Q2, Q3, right? So if it was R12, it was R23, if it was R13. So what was the potential energy of this system? It was 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught Q1, Q2, Q1, Q2 upon R12 plus Q2, Q3, Q2, Q3 upon R23, separation between them, that's it. R23 plus Q1, Q3 plus Q1, Q3 upon R13. Got it? So this was the potential energy of the system of three charges. That means the a pair of the charges, taking the pair of the charges divided by the distance between them plus another pair of charges divided by the distance between them. So that was the way we derived the potential energy of the system of the charges. Similarly, if we have n types of charges, n number of charges. So similarly, we have here three charges. So we have to find the Q if the whole system has zero potential energy. Got it? So let's do it here. Okay. So I hope you got the point. What we have to find in this, we have to find the value of Q if the system has zero potential energy, if the potential energy of the configuration is zero. See, that is U is given as zero. Okay, got it. So it means, you see, isosceles triangle, energy of the charge of the vertices of a right angled isosceles triangle. So right angled isosceles triangle, this side is A and this side is A. If this side is A, what is hypotenuse here? Hypotenuse square is equal to A square plus B square. Okay, A square plus A square, hypotenuse square is equal to 2A square, hypotenuse is equal to root 2 of A. Okay, so hypotenuse is equal to root 2 of A. Now see, that means potential energy is zero. That means first you take this side, Q into Q means Q square upon 4 pi epsilon naught A. Okay, A plus this Q into that Q plus Q into Q upon 4 pi epsilon naught that distance, that is, which is root 2A. Okay, root 2A plus this charge into that charge, Q into Q upon 4 pi epsilon naught A, that is equal to 0. Got it? Because why equal to 0? Because the question is itself speaking that the potential has that the electric potential of this system of three charges is 0. That's why I put equal to 0. Because if the potential energy of the system of three charges is 0, then we have to find the value of Q. Okay. So 1 of 4 pi epsilon naught A, 4 pi epsilon naught A, 4 pi epsilon naught A. So it will go here 0. Okay. So it will be Q square plus QQ plus, it will be plus QQ is equal to 0. Okay, Q square plus QQ equal to 0. Okay, divided by root 2, that will be root 2. Okay, it will be root 2. Yes, it will be root 2. Yes. Okay, now 1 Q will cancel. Q plus Q by root 2 plus Q is equal to 0. We have to find the value of Q. Okay, so it means Q into 1 by root 2 plus 1 is equal to minus times Q. So Q is equal to minus Q divided by 1 by root 2 plus 1. Okay. Okay, let's do it here. So here, I will do it here. Okay. So it means Q into 1 upon, so it means root 2 plus 1. 1 plus root 2 sorry, means Q into 1 plus root 2 is equal to minus root 2 of q. Okay, so it means q is equal to, it means q is equal to minus root 2q upon 1 plus root 2. So it means multiplying by root 2, multiplying by root 2 above and below, that means to both numerator and denominator, it will be minus 2q divided by root 2 plus 2. So this is the option. Okay, so this is the answer. So again I will repeat the question. The question was asking that we have an isosceles right triangle having these at this side equal, and charge to q is capital Q is placed at that vertex q here, okay, and this side and this side are equal because the triangle is isosceles, and we have to find the charge q so that the electric potential energy of whole system of three charges is zero. So again I will see you that we have to find the potential energy of the system. We have to find the value of q such that the system has potential energy zero. So I know that the potential energy of the system of three charges is given equal to zero as the question itself speaks, right? So then we have to add, as we have recently derived the potential energy of the three system of point charges, which was given q square, that is q square into q square upon 4 pi epsilon a into q square into then this combination q into q, that's q into q upon 4 pi epsilon, and distance between them is root 2a, then this combination q into q upon 4 pi epsilon equal to 0, right? Then we have 4 pi epsilon naught here, 4 pi epsilon naught here, 4 pi epsilon naught here. It will go to right side, it will be 0 there because right hand side is 0. Got it? Then we have q square plus qq by root 2 plus qq by equal to 0. Again, q will be common here. Q plus q, capital Q by root 2 plus q. This q will go cancel because right hand side 0. Then finally doing mathematics, we got option B. So these were the questions that has been asked in GW exams, IIT 2002, IIT 2005, right? So I hope it was all for today. Let's meet in the next class. Till then, Allah Hafiz.